Hey everybody, we're going to continue with the fractions today. So last time we learned a great deal of information about fractions, including simplifying, converting between mixed numbers and improper fractions. We also learned how to multiply and divide fractions. So today we're going to learn how to add and subtract fractions. It's a little bit different from multiplication and division. That's why I decided to do it on a separate lecture, separate video. So basically, when you add fractions, we need to have what we call the least common. We need to have the least common denominator. Which we're going to be referring to as the LCD. Okay, so the least common denominator. So basically, when you have two fractions like this, for example, 1/3, and you want to add that to 2/3, what's the first thing you check or you look at when you add or subtract fractions?
What they have in common?
What exactly do we check that has to be common? The
Denominator.
Right? So whenever adding or subtracting fractions, you look at these, they have to be the same. If they're the same, that's good. No big deal. You keep that denominator the same, and you add or subtract the tops based on the operation. That's 3/3, which is 1. Same works with subtractions. So if you have, for example, this minus 1/2, first thing you want to do is check these. We don't need to have a common denominator when multiplying or dividing fractions, as we saw last time. We didn't have to do that. Okay, but with addition and subtraction, you must have a common denominator. So here, same thing. It's good. We can go ahead and subtract. Keep the denominator the same. Subtract the top. So you have 5 take away 1. That's 4/2. And as always, you want to simplify your final answer. So 4/2, of course, that's 2. Okay, so addition and subtraction can be pretty simple if you have the same denominator. But it gets a little tricky if the denominator is not the same. Okay, so for these now, they're fine. Now, what happens when you don't have a common denominator? So let's say I want to add 1/3 and let's say 2/5. Okay, again, first you want to do check the denominators. So these are different. You can't add right away. A lot of people make this mistake just because it seems convenient. They just add these and add these. That's not right. That's totally wrong. You will get a completely different answer. Instead, we need to find an LCD, the least common denominator. In other words, we need to manage somehow to make these the same. These numbers,
15.
That's right. The common denominator would be 15. So we need to find an LCD.
And the reason for that would be because 3 and 5 would go into 15, and that would be the least common denominator, basically.
Exactly. So 3 and 5 are two numbers. So we need to find the common denominator, or in other words, the common multiple of those two. So if you can't see that is 15, it's very simple. Just take both numbers, or more if you have more fractions. Keep doing multiples of both until you find a common number, a common multiple, which also will be the common denominator. What is the first multiple of 3?
6.
That's right, 6. Then
9.
that's another 3, 9. Then 12, and 15. Then you repeat the same thing with 5. The first multiple of 5?
10.
10, that's right. then 15. So once you see that common multiple, that's when you stop. That's the least one. Okay, so the LCD equals 15. The least means the smallest possible. If you keep going this way, 15, 20, 25, and so on, you will get 30, 15, and so if you add 3, you get 18, 21, and so on. You add 5, you keep going. You will find other denominators. You'll find other common denominators, but there's going to be only one least one. Only this one least denominator, and that's the first one that appears. If you continue on, it will be a common denominator, but not the least. And for obvious reasons, we want to deal with simple or smaller numbers. That makes the math faster and the result accurate. Okay, so if you deal with smaller numbers, you're more likely to get it right. And also you can do it faster without needing calculators or doing operations on the side. Okay, so that's probably the simplest way to find an LCD. If you don't know what it is, if you can't see it, just do multiples of both until you find a common denominator. That's just the first step in adding these. We're not done yet. We just found the denominator. Now we're going to try to turn both of these into 15. Once we have 15 here and 15 here, then we can go ahead and add just like we did earlier here. If we have the same denominator, it's simple, you just add the tops. So let's rewrite that, those two fractions, plus 2/5. And basically, I want these to turn into new fractions with the same number here, which is the LCD, which is 15. So I want to have 15 here and 15. Okay, so this fraction will turn into a new fraction. So basically, we turned, how do we turn 3 into a 15?
Multiply by 5.
That's right, times it by 5. And also here by
5.
5. So this fraction will become a new fraction. The ratio is still the same. So what we call last time equivalent fractions. When you times a fraction with both the top and the bottom by the same number, you get a new fraction equivalent to this one. The ratio is still the same, but the numbers are different. So 3 times 5 is 15, 1 times 5 is 5. You may also say how many times does 3 go into 15? That's 5 times. That's why we multiply here by 5. Always times the top and bottom by the same number. So we get 5 here. Now we're going to go to the next one. We're going to try to do the same. We're going to turn this into an equivalent fraction with 15 instead of 5. So here, obviously, we're going to times by
3.
3. That's right. And also 3. Okay, so it's 5 times 3, that's 15. That's exactly what we wanted. And here we have 2 times 3, that's 6. Very good. Now that we have the same denominator, we can go ahead and do what we did here. I'm going to keep the denominator the same. It doesn't add up. Do not add it up. 15 here. And of course, just add the tops. 5 and 6. Get 11. And that's pretty much the answer. What kind of fraction is this, by the way? First of all, can we simplify it?
No.
It's a proper fraction. That's right. Nothing goes into this. Nothing goes into this. Even if we break these down, like we did last time, factoring. This is 3 times 5. 11 is a prime number, can be broken down. So there's no common number between these two. And what type of fraction is it?
Proper fraction?
Is it proper? It is. That's right. So we don't need to write this as a mixed number because it's proper. This is higher than this. If it was the other way around, then we would turn the improper fraction into.
We would have to simplify it.
Yeah, we turn it into a mixed number. But in this case, proper fractions do not turn into mixed numbers because 15 doesn't go into 11. It goes 0 times. So consider this like there's a 0 here and 11 over 50. That's pretty much how you add and subtract fractions. We're going to be repeating the same thing over and over again. Every time there's going to be a different denominator, different numbers here, but the concept will be exactly the same. you find LCD, you turn the fractions into new fractions, equivalent ones with the same denominator, then you either add or subtract depending on this, but the steps are the same for both addition and subtraction. Okay, let's look at another example. Maybe let's do some subtraction this time. Okay, so we want to subtract these two fractions. Can we subtract them right away?
No, you gotta make a common denominator first.
Exactly. So we have different numbers here. We're gonna find the LCD first. What do you think the LCD is?
Least 24, 12. No.
So
yeah.
you may think of 24. You may think about 12.
Yeah, 12. I'm sorry.
Maybe thinking about 36. They're all denominators, but only one of them is the least. Okay. So if you do multiples of both again, if you do 4, then add 4, that's 8. Add another 4, that's 12, and so on. You take the 6, you do the same thing. The first multiple is 12. So that's why 12 is the least. If you continue on, you're gonna get these, but you want to find the least, the smallest one. So it's not always 4 times 6. It's not always 4 times 6. That's the denominator. It is the denominator. Every time you multiply these two, the product is a common denominator, but not the least. But you want to figure out the smallest one so you don't have to deal with large numbers, simplifying, and all that stuff. Let's.
So you multiply.
Okay. That's right. So once you find, let me rewrite the whole fraction here. So once you find your common denominator, okay, so you want to rewrite your fractions. What's in the denominator here?
12 and 12.
That's right, the LCD that we found, which is 12. Okay, so here, the LCD is 12. And multiply accordingly. People sometimes forget to times this. They just turn this into 12 and they forget.
15 over 12, 2 over 12.
That's right. So 4 goes into.
Hello?
That's right. 4 goes into 12 3
I
times.
think your mic cut off.
My mic or yours?
I think my internet connection. I apologize, sir.
Okay, that's all right. The other students, can you guys hear me fine?
Yes, Professor.
Okay. All right. So 4 goes into 12 3 times.
Yes.
Okay. And 5. Since we multiplied here by 3, here we multiply by
3 will be 15.
Exactly. So this is going to be a new fraction. So you got to keep everything proportional. If you change this, you got to change the other one. Otherwise, you've distorted the fraction. You change the number. It's a different number.
Then you're going to multiply these two by 2. Easy. And then you'll get 2 over 12.
Exactly. So 6 goes into 12.
Yes, sir.
Right. Also 2 here. And we get our new fraction with 2 over here. Okay, again, now that we have the same denominator like here, subtraction, we're going to keep the denominator the same, just subtract the terms. So this turn into, that's right, we rewrite this.
6, no, I'm bugging.
That's right, 12 and 15, take away 2, that's 13. Always again, try to simplify your fractions if possible. If not, you want to, can we reduce anything here? Is there anything common between the two?
No.
That's right, nothing goes into 13 and 12 at the same time, but
We would have to simplify.
you mean, what type of fraction is it? I know what you mean. It's not exact simple.
It's a irrational fraction, right?
Improper.
Improper.
Okay, that's improper. We can turn it into what type of number?
1 whole and 1/12.
Exactly, into a mixed number. So 12 goes into 13 ones. Fraction here. Oops.
12 on the bottom and 1 on top.
Excuse me, my pen here is a little slippery. my digital pen. It's very slippery. So we're going to have 1, because 12 goes into 13 once. Then the denominator remains the same, as always. And the remainder will be
1.
That's right, 12 into 13 once, and we have 1 left. That's what goes here. So this is 1 and 1/12. 1 and 1/12 as a mixed number. So always turn your improper fraction into mixed numbers. But first attempt to simplify. Simplify is when you cancel out the common factors after you factor the 2. Then you want to turn that into a mixed number if it's improper. All right, let's now try to do the same thing. Try to maybe subtract some mixed numbers and some whole numbers. Let's say 2 and 1/3. We want to maybe add that to some whole number, for example, 4. 2 and 1/3 plus 4. What do you guys think this is equal to? There's a faster way to do it, but it doesn't always work. And there's the traditional way, which will pretty much follow the same steps. So if you see it, we have 2 wholes and 1/3 plus 4 wholes. So the total easily would be, so the wholes together, that's 6.
6, 1, 1/3.
And 1/3. Okay, so this is convenient and easy without having to turn this into fraction, and then find the LCD. Sometimes it can be convenient and quick, but not always the case. So that worked for this one. But if you have, let's say 1/3 minus, let's say, let's use maybe a mixed number here also, say 4. It's a little bit big. Let's make this smaller. Maybe something like this. So 2 mixed numbers, we want to subtract them. So it may not be as convenient if we subtract the wholes together and subtract the fractions together. Instead, I recommend that you turn everything into fractions first. And then once you have fractions like these, find the LCD if you have to and add and subtract. There might be a shortcut like here sometime. You can do that. You can take advantage of it. Otherwise, just turn everything into fractions. So we have the mixed number here. How do we turn this into a fraction again? First, this remains the same. What else? As we did last time. It goes here to the numerator. How do you turn a mixed number into an improper fraction again?
3 times 1.
That's right, 1 times 3, and we add 2. 1 times 3 plus 2 minus, same thing here. What is the fraction of this mixed number? Let's start with the denominator. What is it? It remains the same, right? Then multiply this way and add this. Times 4 plus, times 4 is 8, plus 1 is 9. Okay, now that's good. So we no longer have, we just have fractions now. What is the next step?
Make a common.
LCD.
Find the least common denominator. That's good. We have 3 and 4. What is the common denominator?
12.
Exactly. So 12. So we're going to times this by 4 to make it 12. Also here by 4. And this one we're going to times by
3.
Very good, 3 and 3. And so the new fractions are 12, 20 minus 27 over 12. Then we can subtract now. The denominator stays the same. And 20 take away 27 is
7.
7, but with a negative. Negative 7 because this one has a higher sign. We're going to talk about the signs in another class. So this will be negative 7. It's proper. It's simple. It doesn't have to be simplified. That's basically the final answer for this question. Okay, so remember with mixed numbers, always turn them into fractions first. They make more sense that way when adding, subtracting, multiplying, and dividing. Okay, is everyone all right? Any questions?
No, Professor.
All right.
Yes, sir.
So let's try to do something else now. Maybe let's say 5. From here, I want to maybe subtract 3 and a half. You can probably think of this as 3 and a half. 5 take away 3 and a half would be 1.5, which is 1 and a half. If you want to do that quickly, otherwise, you can always follow the steps here. Okay, so we have two different types of numbers here. We have a whole number. We also have mixed number. So what do you think we do first here?
Take away from the whole number.
That's a possibility. You can take away 3 from 5, we end up with 2, and then you take another half, you end up with 1 and a half, as I said earlier, but not everybody can see that. So let's try to follow the formal steps here. So we have two different types of numbers, a whole number and a mixed number. First, we're going to turn them into what? We can turn both into fractions, right? We can turn 5 into a fraction by putting 1 in the denominator, and then 2, so we're going to have 6. 3 times 6 plus 1, 7. Now find the denominator. What is the common denominator here?
2.
2. So whenever we have 1 and a number, the other number is always the denominator, because both of those go into this one. Okay, you don't have to do the multiples. Just take only if you have 1 here and another number. So that number will be the common denominator. All right, so we're gonna turn these into new fractions, like so, with the common denominator, the LCD. So LCD equals 2. How do you turn 1 into 2? Of course, we're going to times it by 2, and also 2 here. So you get 1 times 2, 2, 5 times 2, 10. How do you turn 2 into 2? Or what do you times it by?
Multiply by 1.
That's right, basically it's itself. You can think of it as times 1 times 1. All right, so you have 10 over 2, then 7 times 1 is 7, 2 times 1 is 2. All right, finally, we can go ahead and say 2, 10 take away 7, that's 3. Nothing goes into both to cancel out. But this is an improper fraction. What's the mixed number?
1 whole.
1 whole and
1 half.
1 half. That's right, 2 goes into 3 once. You bring over the same denominator, and 2 goes into 3 once. You have 1 left. The remainder, that's what goes here. Okay, so always present your answer as a mixed number, especially if you started with mixed numbers. You want to have your answer as a mixed number. I see when you take tests in the computer, if you have this as a question, placement test or exam, whatever you may take on the computer, and you had options to choose from, you might not see this as an option. Even though you may do this on paper and on the side and you figure out it's 3/2, but you don't see it in the option. Instead, this will be in the option. So you do want to know how to go back and forth between the two, even though your answer is correct, but on the computer, they give you 3 or 4 options. You don't see this, so you need to have to know how to change this. You need to know how to change this into this format of a mixed number. What else? So every time, basically, we kind of repeat the same process. If we don't have the common denominator, we need to find it. And let's see if we can do some more examples. Any questions, anybody, at this point?
No, sir.
Okay, for those of you who came in a little late, make sure you watch this lecture later when I upload it. You missed a little bit in the beginning on how to find LCD. So fractions are very important, as I mentioned in the previous lecture. You do need those for a bunch of other topics. We're going to be using them for equations, for linear systems, for word problems, and a bunch of other things. So you're also going to need this in college algebra. The next class after this one is college algebra, and you're going to be going through this fast. You will not be learning how to do fractions. You will be assumed that you know them. So the professor would just go right through them without explaining why. So you need to know your fractions before you get into college algebra. What else? Let's see. Yeah, it's pretty much the same process repeats itself now. Let me see if we can do one more example here. And then we're going to start doing some word problems. Okay, one more here. Say 4 and 1/3 plus, oops, and maybe 1/2 or 2/7. Okay, subtraction of mixed numbers. So again, we're going to turn this into fractions first. So before we turn this into, before you find the LCD, you want to turn this into fractions. So we're going to mix number. First, you want to write the denominator. For now, it stays the same. Times these two, add 1, that's 13. Here, the denominator stays the same, that's 7. 1 times 7 plus 2, 9. Now you can find your common denominator. What do you think it is for 3 and 7? What is the common denominator for 3 and 7?
21.
21. That's right. If you don't see it again, you can do the multiples. 3, 9, 3, 6, 9, and so on. Here's a trick here. If both of these are prime, meaning we can't break them down into other numbers, then the common denominator is just the multiplication of the two, if both of them are prime. If not, if they're not prime, then the denominator will not be that. As an example here, earlier, you had 4 and 6. Someone told me earlier that the common denominator is 24, the least common denominator. 4 times 6 is 24. It is a common denominator, but it's not the least. So we had to do the multiples in order to find the common denominator. Why isn't it the common denominator at the least? This one is not the least because these are not prime. Both of them can be broken down. For example, this is 2 and 2, this is 2 and 3. So you can't take the multiplication as a prime. Only if both the denominators are prime, that's when you take the LCD as their product. you don't have to do the multiples. That's for a fact. No need to do all this 3 and 3 and 9 and 6 and 9 and 12. Just take the 2. And also, like I said, if one of the numbers is 1 and the other one is a number, the other number immediately is the LCD. Okay, so these are some tricks you can use to quickly identify the denominator. It's not always 3 times 7, only if both of these are prime, like I said. Okay, so now that we have the denominator, so we're going to turn both of these into this 7. How many times does 3 go into 21?
7.
That's right, 7 times, also here by 7. How many times does 7 go into 21?
3.
3 and 3, that's right. Now we're going to times these. What's 13 times some 7? That would be?
91.
That's right. And here, of course, 9 times 3, that's 20.
27.
Okay, and put 21 here. If you subtract the 2, 91 take 27. Again, all the math would be done manually since we this class, we're not allowed to use calculators and or phones or computers. We're gonna try to do everything manually. So for something like this, 1 take away 7, I'm gonna have to borrow 1 from here. Turns into an 8, 1 here, 11 take away 7. It's 4, 8 take away 2, that's 6. And 6 to 4 here.
Okay.
Okay, now attempt to reduce this fraction. Do you think, or can we reduce this fraction?
No.
Okay. Why do you say so?
Sorry, never mind. Yes, you can.
By?
3 wholes.
That's right, by 3. So here's another trick. Obviously, 2 does not go into both, right? Because this one is even, this one is odd. So 2, we cannot divide it by 2. Here's a trick to figure out whether numbers can be divided by 3. Just add up their digits. And if the sum of the digits is divisible by 3, the number itself is also divisible by 3. Here's what I mean. What is 2 plus 3? I mean, 2 plus 1.
3.
3. Can you divide 3 by 3? Of course. That means the number itself can be divided by 3. Can we divide this number by 3?
Yeah.
Yes. Why?
Wait, did you say 6? Hold on. Yeah.
Can we divide it by 3?
No, I don't think you can.
Why not? Because 6 plus 4 is 10, right? We can't divide 3 by 10. We can't divide 3 by 10, right? Or 10 by 3. Therefore, we can't divide this one. Unless it was, I don't know, probably 66. If this was 66, 6 plus 6 is 12. If you can divide 12 by 3, you can also divide 66 by 3. Okay, so 3 does not go into both. So that's basically it. This cannot be reduced. You can also look at
wow.
Let's also look at it this way. 7 and 21 is basically 7 and 3. None of these two go into 64. 3 does not go into 64. 7 does not go into 64. So there's no number that can reduce, that can go into both at the same time. So these are some tricks to see whether you can divide a number by a number. Again, add these digits. And if the digits add up, or if the sum of the digits is divisible by 3, you can divide the number by 3 as well. For example, 123. Can you divide this number by 3?
Yes.
Is this number divisible by 3?
Yes.
No.
Yes and no. Which is it?
Yes, it is.
Yes, it is. We can check by adding these 3. So if 1 plus 2 plus 3 is 6. If you can divide 6 by 3, which we can also divide the number itself by 3. Okay, keep that trick in mind. You can use it. Another trick is if both numbers are, I mean, this one is common. If both numbers are even, we can divide them by. We can reduce this by, since they're both even. That means there is at least one number that goes into both, which is
Part2.
2. That's right. Here's another one. If numbers end in 5, they're divisible by 5. 5 or 0. Any numbers that end up in 5 or 0 are divisible by 5. For example, 50 and 25. You can divide this by 5. Same here. So this is by 5, this is by 2, this is by 3. At least know these 3 tricks. They can make your things or your life a lot easier in math. You can simplify things quicker and faster. Back to this one. There's one more thing we can do here. What is it? We can turn this into
Mixed number.
mixed number. How many times does 21 go into 64? 21, 21, 21. How many times is that? What's the whole part?
3.
3 times. Same denominator, 21. This is 3 times. So how much is left if you subtract this from this? Would be 1, right? So 3 times 21, 3 times into this, and it's a 64, 63. You have 1 left from that. Okay. Okay, there's plenty of tricks you can play with around. So the more tricks you learn, the better. That's how you get better and better in math, and you do things faster. And of course, it requires a lot of practice to get used to all this. But at least remember these main tricks here that I showed you. What else? I believe that's pretty much it for addition and subtraction. Probably going to do a couple of word problems using these, and will be it. Please mute your mic if you have background noise. I hear some loud stuff. I believe that's you, Gavin. So
Sir,
this,
said that you muted me.
yeah, I was hearing some background noise. It was coming from your side, I believe. Right?
I'm sorry.
No, that's okay. I can see here when
I've been having network problems. I'm sorry. That's why I've been like not saying much, because it's been like hard to hear you sometimes, and then like I feel like when I'm saying something I get cut off.
Oh, I see. I see. Yeah. It looks like that.
Now though,
I understand. Yeah. Yeah.
I'm sorry.
But I believe it's just you having that problem.
Yeah.
Everybody else can hear me fine. Right, guys?
Yes, sir.
Yeah.
Okay. So, Gavin, it's all right.
Sorry.
No problem. All right. So this is the second part of the lecture. Word problems should be word, not words. Okay, word problems with fractions. This is common stuff in the homework and the exams. Give you a word problem, and you figure out what to do with the fractions. It's up to you to understand the problem and either add, multiply, subtract, or whatever with word problems. Let's say you bought $3 1/5.
Please leave your message for
3 1/5. Gallons of something. What is it, of paint? And used maybe 1 2/3 of it, how much paint is left? Okay, so this is a typical question you'll see about fractions. First, you want to understand your problem. So you bought 3.5 gallons, 3 1/5 gallons of paint and used, let me correct the punctuation here. We don't need this here, we don't need this there. We just need a comma, period here. Okay, you bought 3 1/5 gallons of paint and used 1 2/3 of it. How much paint is left? So we understand this. So what is the operation? Obviously, it will be, what is operation?
3/5 minus 1 2/3.
Exactly. So obviously here, so we bought, oops. So if you use that, so the answer is 3 1/5 minus 1 2/3. So you have to figure out the operation and then perform that operation. 3 1/5 minus 2/3, and basically you're gonna repeat this again. You may have to read the problem a few times before you understand it. It's not a problem. You just read it till you get it and decide what operation to use. Okay, let me go through this quickly. So 5, 15 plus 1, 16 minus 3. And so we have 1 times 2 plus 3, that's 5. Oops, that's not what I wanted. That's 5. What's the LCD here?
$11.
The LCD, the
Oh,
common
sorry, I wasn't paying attention.
B, 15, right?
15.
Right, so we're going to times this by 3 and 3. 16 times 3 will be, what is it?
48.
48. Very good. And of course, here we're going to times this by 5 by 5. 5 times 5 will be 25. Finally, at 15. And 48 minus 25. You want to do that on the side, right? So that's 3 and 2. Okay. Are we done with the answer, or do we need to do something else? Is there anything else we need to do here?
I don't think so.
Make it a mixed fraction.
That's right.
Oh, yeah,
Exactly.
yeah.
You can't reduce. Always try to reduce first. Since we started with mixed numbers, you want your answer to make sense. So 3 1/5, 1 2/3 make more sense than 23 over 15. What is 23 over 15? We don't know. So, but if we turn it into a mixed fraction, it will make more sense. How many times is 15 going to 23?
Once.
That's right, once. Same number here, 15. And what's the remainder? If you subtract 15, you'll get 13 minus 5, which is 8, and 0 here, right? 1 minus 1, make your 8 left. And the answer should make sense. So if you subtract, if you use this much, this is the whatever the amount we bought, if we use this. So you expect your answer to be less than the amount that you bought. If you get, for some reason, you get 10 here, 10 gallons and 2/5, that would not make sense. You should get less than what you bought. You bought this, you consumed some of it, so you'll have something less than this. So always kind of try to logically check your answer, see if it makes sense or not. If not, you gotta go back and verify, check your work. Let's do another one, another common problem. If you bought, or if, yep, no problem. If you used, or if you bought, or if you purchased, let's say, 2.5 pounds of fruits for, let's say, $1.75. Okay, that's $1.75 or $1.75. $1.75 per pound. How much you paid, or how much was the total? Okay, so again, with a word problem, first you want to understand it, figure out what operation to use, and then do that operation. So you purchase 2.5 pounds of fruits, and each pound costs $1.75 or 1 3/4 per pound. How much did you pay in total?
So you would multiply.
Exactly, multiply. So another trick here, when don't let the mixed numbers fool you or make it complex. If you see something like this, you might be thinking too much and stressing out about mixed numbers. If that stresses you out, just forget about those. Use some simple numbers, for example, 8 and maybe 5 here. So if you bought 8 gallons and used 5, how much is left? Forget about the mixed numbers. Say you bought 8 gallons of paint, you used 5 gallons. How much of it is left?
3.
3. So what operation did you use in your head? Of course, you used subtraction. That's how you know that you're going to be using subtraction for these as well. That's why we used it here. Okay, so sometimes people focus on the numbers. They think they're complex. The problem is complex itself, but it's not. That's one way. So again, you can always try this on the side with smaller numbers, easier numbers. Once you figure out the operation, then you can go ahead and use that operation. So again, here we said we're going to multiply. So 1/2 times 1 3/4. So we saw the multiplication of mixed numbers last time. What is the first thing you do again? What do you want to do first when you multiply mixed numbers?
Turn it into a fraction.
Exactly. Turn them into fractions. So we have 2 here, 5 times 4 and 7. How do you multiply fractions again? Which way? Or what is give me the product of this.
5 times 7 and 2 times 4, so it would be 35 over 6.
Or 8, right?
8.
That's right. So just multiply straight across. Unless it was a division, then that's when you keep change flip. Nothing goes into 35 and 8, but we can turn this into
a fraction.
That's right. How many times does 8 go into 35? 8 times 4 is? 8 times 4?
32.
32. So 8 into 35, 4 times. 8 here. What's the remainder? 32 from 35 would be?
3/8.
That's right. 4 and 3/8. That means $4 and some change here, if you want to turn that into decimals. Or you can add the unit if you want. Okay, when you have a word problem, you do want to add the unit at the end. So here we have gallons. Okay, gallons. I believe the abbreviation for the unit, I believe, is GAL. Okay, so you use, or you can just write gallons. Okay, don't forget the unit with word problems. We want to know what exactly are we calculating. So this is the final answer here, final answer here. And that's pretty much it. The word problem the words might differ from one problem to the other, but the process of solving is pretty much the same. I can write 10 different problems using the same numbers, just different words. It will still be the same method. I believe that's about it for addition and subtraction of fractions. Of course, you're going to see plenty of these in the homework to practice for yourself. Do you guys have any questions about any of this?
No, Professor.
Okay, everybody else, you guys okay? The rest of the class, you guys all right? Any questions, any confusions?
Good. No, there are no questions.
Send you a picture of the work.
You said you're taking a picture?
Yeah, will we be able to do that?
Yeah, sure. I'll also upload this video, as you know. I'm gonna upload it to the homework folder, the whole lecture, and you can rewatch the whole thing.
You gotta put it on Blackboard?
That's right.